So lesson 5.4, which is really just a continuation of 5.3. 5.3 is the introduction into this, and this is where we kind of really get into our trig ratios between 0 and 360. So we'll work our way through a couple of these examples. Question 1 is graph the equation x squared plus y squared equals 25. Now we should remember that that's the equation of a circle, right? The equation of a circle is x squared plus y squared equals r squared. So x squared plus y squared equals 25 tells us that r squared is equal to 25. So r is equal to the root of 25, which is, remember, both positive and negative 5. When we take the square root of 25, we get a positive and negative root. That gives us our points for our circle. So I have one at 5, and I'm going to go by these dark lines as 1. So 1, 2, 3, 4, 5. I'm going to put it here just to kind of spread out our circle. And then 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And negative 1, negative 2, negative 3, negative 4, negative 5. So if I want to create a circle, there's my 4 points. Now it tells me the point P at negative 4, 3 lies on the circumference of that circle. So at an x value of negative 4, negative 1, negative 2, negative 3, negative 4, positive 1, positive 2, positive 3. So here I have point P. Now that lies on the circumference of that circle. So as I connect my points here, we're going to attempt to make this look like a circle. There. So I have my circle with point P sitting on that circle. Now, what we can do is take my point P here and connect it to the origin. And then I can connect it down to my x-axis, creating a right angle triangle. And from point P, I know my x value is negative 4, and my y value is positive 3 for point P. So over negative 4, up 3, gives me point P. So what I need to do here is find the hypotenuse of the triangle. So to do that, we're going to do Pythagorean theorem, c squared equals a squared plus b squared. So c squared is what I want to find. A can be either one of these, 3 squared plus negative 4 squared. 9 plus 16. C squared is equal to 25. C is equal to root 25, and C is equal to plus and minus 5. Now, because we're finding the hypotenuse, of course, we're not worrying about the negative, right? Because the hypotenuse is always just going to be positive. So when you take the square root for Pythagorean theorem, in this case, we're only dealing with the positive 5, which we get here. Now, what we notice, if we look at this for a minute, is that the hypotenuse of my triangle is the exact same as the radius of my circle. If this is the radius from the origin to the outside of my circle, it's also the hypotenuse of my triangle. So x squared plus y squared equals r squared is in fact the same thing as Pythagorean theorem. C squared equals a squared plus b squared. So the equation of a circle is the same as Pythagorean theorem. Now that we have our 3 sides labeled, we want to determine the principal angle and the related acute angle. So our principal angle, if you remember, goes from the positive x to my terminal arm, and we let theta represents the principal angle. And then my related acute angle is inside the triangle, and we usually let beta, or B, represent that angle. So I want to find my acute angle in here first before I can find the principal angle. And to find this acute angle, I'm going to use a primary trig ratio. I can use sine, cos, or tan. Now you can use all three. So if we use sine, for instance, sine of angle beta is opposite over hypotenuse, 3/5. Cos, adjacent over hypotenuse, -4/5. And tan is opposite over adjacent, which is -3/4. The reality is you can use any of those three trig ratios you want to find the angle, but my suggestion is to always use the positive trig ratio. So remember from last lesson, the cast rule, and based on the cast rule, sine is positive in quadrant 2, right? 3/5. If you use cos or tan, that's okay. Now, cos in this case is actually going to give you the principal angle, not the acute angle. So to keep things simple, it's always best just use the primary trig ratio that is positive for that quadrant. It makes things a whole lot easier. So because sine is positive, then to find my acute angle, which is beta, I'm going to do the sine inverse of 3/5. And when I do that, I get an acute angle of 37 degrees. So my angle here is 37. Now to get the principal angle, because I'm in quadrant 2, I'm going to do 180 subtract 37. And when I do that, my principal angle is 143. So to find the principal angle, you always need to find your acute angle first, and then once you have the acute angle, you can then determine the principal angle. So using this example, we're going to move down here, and we're going to graph x squared plus y squared equals r squared. But I'm going to plot the point pxy. So I can put that anywhere here on my grid. Now because x and y are positive, I'm going to put my point here. So this is point P. And I make my triangle. Now in quadrant 1, I'm not going to use any numbers, but we know that this is the x, right, because it occurs on the x-axis. This is the y. And this, we now know, is the hypotenuse, but it's also the radius of our circle. Because if I was to take this point and create a circle, point P lies on that circle, which makes this the radius. And my principal angle in quadrant 1 is right here. The principal angle and the acute angle are the same. Now, if we look at our primary trig ratios, sine is opposite over hypotenuse. Opposite over hypotenuse. So sine is equal to y over r. Or we can look at cos, adjacent over hypotenuse, or in this case, x over r. And tan, opposite over adjacent, which is y over x. So when you're dealing with your triangles in coordinate geometry or in the 4 quadrants, we get away from using opposite, adjacent, and hypotenuse, and instead we use x, y, and r, because in reality we're dealing with coordinates now, as opposed to lengths. So for instance, you can be down here in this quadrant where you have a negative x value and a negative y value. So that's why we refer to them as x, y, and r, as opposed to opposite, adjacent, and hypotenuse. One other thing that we're going to be discussing is something referred to as a unit circle. And a unit circle is simply a circle that has a radius of 1. 1 unit is the radius of that circle. Now we're going to look at what happens when we sit on the axis. So for example, what happens when your angle is 0 degrees? So we'll just create our circle. I'm sitting at 0, so I'm literally right here. At 0 degrees, my initial arm and my terminal arm are sitting directly on top of each other. So in this case, the length, if you can see that, is 1. It's 1 unit long from the origin to my circle. So if sine of 0 degrees is equal to y over r, for this line, if I'm at 0 degrees, my y value is going to be 0, and the radius of my circle is 1. So 0 divided by 1 is 0. If I look at the cos of 0 degrees, that case is x over r. So x is 1, and r is 1. And then tan of 0, which is equal to y over x, my y value is 0, my x is 1, I'm left with 0. And that is why on our calculator, if you type in the cos of 0, you get an answer of 1. Because cos is x over r, and at 0 degrees, your x value is 1, and your radius is 1. Or your x value is going to be the same length of your radius no matter what size your triangle, or sorry, what size your circle is. What happens when the angle is 90? So we're going to do the same thing. We're going to draw our unit circle, as horribly as that is. Now, I'm sitting here at 90 degrees, the radius of 1. So sine of 90, which is y over r. In this case, my y value is 1 and my radius is 1. So the sine of 90 is 1. If I look at the cos of 90, which is x over r, x is 0, r is 1. So that's 0. And the tan of 90, which is y over x, y is 1, and x is 0. And 1 divided by 0 is undefined. And that's why on your calculator, if you type in the tan of 90, you get an error message because you can't divide by 0. So you cannot actually evaluate tan of 90. You can't find the tan of a vertical line. Moving to 180, which is over here. We have our circle. Radius is sitting here at 180. Sine of 180, y over r. My y is 0, r is 1, 0. Cos of 180, which is x over r. My x value here, because I'm on this side of the y-axis, even though that length is 1, because I'm on the left-hand side of the y-axis, my x value is actually going to be negative 1 over 1, which is negative 1, which again, on a calculator, cos of 180 gives us negative 1. Tan of 180, y over x, my y value is 0, my x is negative 1, and that's why the tan of 180 is 0. And then 270 down here. We'll create our circle again, sitting here. Again, radius of 1. Sine of 270, y over r. Y is negative 1, right? R is 1. So the sine of 270 is negative 1. Cos 270, x is 0, r is 1. Because the radius always has to be positive. X and y values can be negative, And finally, tan of 270, y over x, gives me a y value of -1, x value of 0. And again, we're undefined at tan 270 because we have a vertical line. Now, the reason why I went through those 0, 90, 180, and 270 is because those are also exact values. They are considered to be special angles, just like 30, 45, and 60 from lesson 5.2. Because these give us exact values as an answer, they are also referred to as special angles. And that is why we use x, y, and r as opposed to opposite, adjacent, and hypotenuse. For example, if I'm asked to find the sine of 90, and it's 1, well, at 90 degrees, if I have a vertical line, I can't use opposite, adjacent, and hypotenuse because it's not a right angle. I don't have an opposite side. I don't have a hypotenuse. So in order to find my trig ratios, I have to use x, y, and r because opposite, adjacent, and hypotenuse don't work. So the equation of our unit circle is x squared plus y squared equals r squared. But in the unit circle, the radius equals 1. So my r is in fact going to be 1. So x squared plus y squared equals 1 is the equation of a unit circle. So if sine theta is equal to y over r and cos theta is equal to x over r, in a unit circle, we've just mentioned that the radius is 1. So I put a 1 in here for r. So therefore, that means that y simply equals sine theta and x equals cos theta. So if you're looking at a circle and you want to find a specific point, the x value is the cos of the angle and the y value is the sine of that angle. A reminder from 5.3, our cast rule, C, A, S, T, for which trig ratios are positive. Okay, quadrant 1, they're all positive. Quadrant 2, sine is positive. In 3, it's tan. And in 4, it's cos. And that's going to be really important kind of moving forward as we take a look at some of these questions. So for question 1, determine which quadrant the terminal arm of the principal angle lies, the value of the related acute angle, and the sign of the ratio for tan 110. So for all of these questions, it's always best to start off with just a little tiny diagram for a visual. 110 degrees, we know is between 90 and 180. So I can put a terminal arm in here. And if it's 110, I know that that's my principal angle because it's greater than 90. So that's 110. So if I want to find my acute angle, which we can label as beta, this angle here, I know I can determine that by simply doing 180 subtract 110. And my acute angle then is 70 degrees. Determine all values of theta to the nearest degree. Now, when we see this, a lot of students start freaking out because they think, well, what does that actually mean? All that means is that we're looking for all angles between 0 and 360. So we're looking at all 4 quadrants. If they just want you in the second quadrant, it would be 90 and 180. If they want the third quadrant, it would be 180, 270. Because our limits are between 0 and 360, we're looking at all 4 quadrants. So tan theta equals negative 0.1623. The first thing we want to recognize is that this is a negative decimal. And if it's negative, it tells us which two quadrants we're looking at. Because tan is negative in quadrant 3, it means it's negative in 2 and 4, right? There's always two quadrants where tree ratio is positive and always two quadrants where tree ratio is negative. Tan is negative in 2 and 4. So when I draw my little sketch, I'm going to put my terminal arm in quadrant 2 and in quadrant 4. Now I need to find what angle this is. So to find theta, we're doing the tan inverse of negative 0.1623. And when we do that, our calculator, as we round it, gives us an angle of negative 9 degrees. I want to mention we're using theta here, even though we're finding an acute angle. Sometimes we use beta. It's interchangeable. It really doesn't matter. You can use theta for an acute angle and a principal angle. It's just what they use in the question. So negative 9 degrees, if you remember, it means we're going clockwise 9 degrees. So this angle will be 9. Remember, between the terminal arm and the x-axis is where we put our angle, not the terminal arm and the y. It's always between the terminal arm and the x. So if this is 9 degrees, my other acute angle is going to be 9 degrees as well. Once I have my two acute angles, I can now find my principal angle. This one and this one. So the first angle I'm looking at is 360 subtract 9 degrees, which is 351. My second, let's do 180 subtract 9 degrees, which is 171. And those are all my angles. Now, I did round this slightly to get negative 9 degrees. It wasn't exactly negative 9. But if I type in the tan of 9, I get 0.158. So it's not exactly 0.1623. But what if I type in the tan of 351? I get pretty much the same decimal, 0.158, except it's negative because I'm in the quadrant where tan is negative. And if I type in tan of 171, I get the exact same decimal, but negative because I'm in that quadrant, quadrant 2, where tan is negative. And tan of 9 gives me the exact same decimal. So the fact of the matter is we end up with 3 angles, an acute, and 2 principal, that give us the exact same decimal for the tan. Now, if I didn't round, all 3 would give me this exact same decimal, because all 3 are equivalent to this. But because I rounded, that's why it's 0.158 instead of 0.162. For the next one, CSC, this brings us all the way back to lesson 5.1 with reciprocal tree ratios. So cosecant, CSC, is the reciprocal of sine. So I can switch this to sine theta equals negative 3 over 2 root 3. Again, we know it's the sine. It's negative. So when I draw my 4 quadrants, I'm putting my terminal arm in the 2 quadrants where sine is negative. Sine is positive in the top 2, in quadrants 1 and 2. So sine is negative in the bottom 2. So I create my 2 terminal arms. I'm in these 2 quadrants because these are the 2 quadrants where sine is negative, based on the cast rule. I need to find this angle. So I'm going to do the sine inverse of negative 3 over 2 root 3. And when I do that, I get negative 60. Again, the negative just implies direction. So I'm going 60 degrees clockwise. So this will be 60, and this will be 60. Again, terminal arm, x-axis. Terminal arm, x-axis. I'm not going here next to y, right? My triangles always get formed with the x-axis. So now that I have my two acute angles, I can determine my two principal angles. So first one and second one. So in quadrant 3, I'm doing 180 plus 60, which gives us 240. And then the other is 360, and we subtract the 60, so it's 300. So again, if you type in the sine of 60, the sine of 240, and the sine of 300, you'll end up with the same decimal. For C, tan, what do we notice with that decimal? We notice that tan is positive now. So with tan being positive, I know I'm going to be in quadrant 1 and quadrant 3. So I draw my terminal arm in those two quadrants. I need to find the angle. So to find the angle, I'm doing the tan inverse of 2.3151. And I get an angle of 67. So my acute angle is 67 here, and it's also 67 in this angle. To determine my principal angle, well, in this first quadrant, that is my principal angle. It's a principal and the acute, so that's already there. For my second principal angle, I'm going to be doing 180 plus 67, 247. And because 67 is in the first quadrant, in this situation, I'm only getting two angles. I'm not getting three. Because in that first quadrant, the acute angle is the principal angle. For D, cot, reciprocal of tan. So tan is equal to 1 over 8.1516. Remember from 5.1, taking the reciprocal, and it's positive. So just like question C, I'm in the two quadrants where tan is positive. So I'm going to be in 1 and 3 again. So to find my angle, it's going to be the tan inverse of 1 divided by 8.1516. Whoops. And that gives me an angle of 7. 7 degrees, 7 degrees. Again, this is the acute angle and the principal angle. So my other principal angle will just be 180 plus 7, 187. So you do this anytime you have a question that asks for all the values of theta between 0 and 360. We're looking for all those angles that give us the exact same decimal between 0 degrees and 360. If angle theta is a principal angle that lies in quadrant 2 and cotangent is negative 4/5, determine the exact value of x, y, and r. So We're in quadrant 2, which is here. Now, we're dealing with cotangent, which is a reciprocal trig ratio. I don't like reciprocal trig ratios because you can't do anything with them. I want to do something I'm familiar with, which was tan. So I'm going to flip this back so that tan theta is equal to negative 5/4. I'm going to flip it back, right? Take the reciprocal. And from earlier, we know that tan is equal to y over x. So 5 is my y value, 4 is my x. So let's go, we'll go again with the darker line. So we'll treat it as 1, 2, 3, 4 is my x. And 5 is my y. 1, 2, 3, 4, 5. And if we match those up, this is my triangle. So, in this case, because I'm in this quadrant, my x value is negative, so that's going to be a negative 4. And this is going to end up being a positive 5. Based on the location of which quadrant it's in. So I need to find the exact value of r, my radius, or my hypotenuse. So to do that, it's Pythagorean theorem, but instead we're going to use x squared plus y squared equals r squared. So x is negative 4, y is 5, and we want to find r. 16 plus 25 equals r squared. So 41 is equal to r squared. So the root of 41 is equal to r. And because we want an exact value, I'm leaving that as a root. I'm not changing it to a decimal. So this becomes root 41. And again, it's the positive root, right? Because it's a radius. It's a hypotenuse. It's a length. So it's positive. So my exact values, x is negative 4, y is 5, and r is the positive root of 41. Sketch angle theta in standard position. Well, theta, my principal angle is this. So in order to find my principal angle, I need to find my related acute angle. And again, because I'm in this quadrant, sine is positive. I'm going to stick with sine. So my angle is equal to the inverse of sine y over r, 5 over root 41. And that gives me my acute angle, which is 51 degrees. So this angle in here is 51. And to find my principal angle, 180 minus 51 is 129. Given the point PXY lying on a terminal arm of angle theta, determine the primary trig ratios for P at -1, -1. So I'll draw my 4 quadrants. Now, -1 is my x, -1 is my y. So I'm going to be down here. So we'll make our triangle, again, always with the x, never with the y. So x is -1, and y is -1. And we want to determine our primary trig ratios. Now I'm just going to stop here for a second, because what happens, or what do we know about a triangle that have 2 sides that are the same length? And if it's a right angle. means that the angles are going to be the same. It means that this angle is 45 and this angle is 45. Because if the two sides are the same length, the two angles must be the same as well. So now, that's 45. Let's see what we remember from lesson 5.2. If I want to find the sine of 45, what's the sine of 45? Root 2 over 2. And if I want to find the cos of 45, it's also root 2 over 2. And if I want to find the tan of 45, remember that's 1. And that's because with this triangle, if I did Pythagorean, or x squared plus y squared equals r squared, I get negative 1 squared plus negative 1 squared, 1 plus 1, which is 2, and root 2 is equal to r. So we know that we need to rationalize it, because we can't have a root 2 in the bottom, and that's how we get our primary trig ratios. For question 5, angle theta is a principal angle that lies in quadrant 2. Given the trig ratio CSC is 2.5, determine the exact values of x, y, and r. So if I'm in quadrant 2, here, and cosecant is 2.5, in order to determine my psi lengths, I can't have just this, 2.5. I don't have an x value, a y value, an r value. I have nothing. So what we need to do is we need to get rid of that decimal. So 2.5, we're going to convert it into a fraction. So if we do that, CSC becomes 5 over 2. Right? Because that's 2.5. You convert that to a fraction. Or, for those of you that have difficulty with it, you can do 2.5, press the fraction button, it'll convert to 5 over 2 for you. Cosecant is 5 over 2. I switch it back to a primary trig ratio, which is sine. So sine is equal to 2 over 5. And we know with sine is equal to y over r. So my y value is 2, my r value is 5. I just need to determine my x. X squared plus y squared is equal to r squared. I want to find x. Put in my values for y and r. Well, it's 25 minus 4. X squared equals 21, which means that x is equal to root 21. So x is root 21. But what I've been talking about since the beginning of this lesson, going back to, let me grab it here, the first question. Here, I said when you take the root, you get two answers, a positive and a negative. For the radius, or for the hypotenuse, it always has to be the positive, right? You stick with the positive root. However, when you're solving for x, you have two answers, the positive and the negative. And the reason why you're getting two answers is because there's two locations where this triangle can occur. It can occur when x is negative root 21, and it can also occur in this quadrant as well, right? Sine is positive in quadrant 1, so that would still be 2, that would be 5, and this would be positive root 21, because sine is positive in those two quadrants. So you have to be careful when